If you think about buildings, they're actually the sum of the behaviors that are associated with the buildings. It's the behavior of the designer, it's the behavior of the operator, it's the behavior of the tenants, it's the behavior of the people who take care of the landscape. All of that kind of stuff goes together. But it's also worth noting that the more data you have, it changes your frame of reference. We did our first energy reduction plan in 1974. It was a different energy crisis back then. From 1985 to 2005, commercial buildings in the United States have had no net change in energy consumption. They're just as bad as they were 30 years ago. At the same time, GSA cut 30% of its energy consumption out of its portfolio. The federal government wide, with 500,000 buildings in the United States, and 4.5 billion square feet of space, reduced by 27%. So it's doable. And so if you want to know what we did, that's a different story. But the other thing that's happened too in those same years is that plug load and lighting, those things that are really associated with tenants, have gone up as a percentage unbelievably from 15% to, in 1985 to nearly 45% today. Judy?
And I love the little quote, I don't know if all of you saw it in Kathy's slide, that said, it was a fine building until the people moved in. Who do you think we're designing for? That's an amazing statement. So we're going to look at whose behavior are we talking about? And when we say occupants, there's a lot of occupants in the building who play very different roles and who have very different relationships to sustainability and energy and so forth. And a lot of the work we're doing is looking at how do we break down messages about energy and get research into practice by focusing on different target audiences. And if we look here, the workers have very different kinds of preferences for comfort. I'm going to show you some research we've done on that. Building operators are very concerned with tracking building performance, and in the government right now, the mandates and executive orders have really strict goals in mind, and so the energy of the building operator really has to track those and report them. So their role then is different. They're looking at different kinds of things. The managers in the building, they set the performance goals, and whether they care about sustainability or not is a huge issue. And the decision makers, set goals for the organization. A lot of the plug loads we're seeing are mission-oriented plug loads. They are the big equipment that people bring in to sort of have video conferences. They are data centers that have to keep things up and running. So there's a lot of things that come in that are really part of the organization's mission. And they also make decisions about money. So we're looking at targeting things for the money managers, the decision makers who really care only about, or primarily about, how much is it going to cost me and what do I get out of it. And then we've got purchasing. We found through some work we've done that purchasing is a huge barrier to getting things done in the government, because if people don't specify green products, if they don't specify Energy Star equipment, that there's a roadblock right there. So how do we get to those purchasing folks? And the government now has an initiative with GSA, the Federal Acquisition Service, EPA, DOE, looking at eco-labels and green product standards that will be rolled out sometime soon. And I think, Kevin, you're?
Yep. Somehow. So anyway, one of the things that we thought we'd look at is this purchasing and picking up, and I'm glad Kathy mentioned energy savings performance contracts. In Southwest Germany and in municipalities there, the average energy savings performance contract cuts 45% of the energy out with a 10-year term. In the United States, it's 20% with a 20-year term. So what do they know that we don't know? Well, by the way, they're dealing with the same firms. Siemens works there, Honeywell works there, Johnson Control, it's the same firms. So what do they know in Europe that they don't know here? And the answer is nothing, but we do things differently here. So what we decided to do was set a audacious challenge. We'll take a fully occupied building, existing building, and you do an ESPC and give us a net zero building as a result. Now, we know that with no capital from the owner, that's not likely to happen. And of course, one of the big barriers that we had to overcome is none of my colleagues actually like to set a goal that you couldn't achieve, but at least it was something that you knew what the target was. It's not like that you can get better than net zero. You can be net positive, that would be great, but getting even close. And we started out with a really look at how the parties interact. And what in an energy savings performance contract, what you do is you very tentatively bring two parties together, sit them down at the table, and they stare each other in the face and they think, oh my God, I'm taking all the risk. But not both sides think that. The owner thinks that, and so does the ESCO think that, and they're providing a guarantee. We asked both sides of the equation across the federal government, so what's the barrier to new technologies? And all of the ESCO, well, you know, you guys won't accept them. We propose this, 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 and this over and over again. So, of course, then I ask all the contracting people in the government. They say, well, you know, we never see proposals for that stuff, and we can't sort of dictate what they're going to guarantee because it's their guarantee. So we have a wonderful thing that used to be called the GSA Salute. It's not me. So, yeah, at any rate, we did this challenge. We brought people together. You know, we pulled them together at the Rocky Mountain Institute for a charrette and said, what can we do? And everybody, the number of ideas in a day and a half was absolutely phenomenal. Number one, everybody admitted integrated design, when you're focusing on energy, just goes out the window because it's a construct where this energy measure has this kind of result. And then they just add up. Well, they don't add up, they interact. And so if you could get to the interaction, which makes some other parts a little bit more difficult, that works fine. Project economics, the same thing. Anybody who wants these details, and of course you can't read it, I can't read it either, but this is just to say we have a whole lot of ideas. So anybody who wants to steal these ideas, they're already up on our website, go ahead and look at it. The delivery process. Occupant behavior has never been measured in an energy savings performance contract because people think it's too hard to guarantee, but if you don't do it, you're leaving 40% of your potential energy savings on the table, so you have to do it in some way or another. We looked at measurement and verification, we looked at all the rest of the kind of things. The number one thing we found was that the time spent negotiating these contracts basically eliminated 15% of the potential energy savings, because that time all went to pay overhead and risk mitigation. And so we wanted to really, you know, figure that around. So we put up 30 of our own buildings and we said, here's a contest, everybody can participate, and what's the prize? What motivates companies in this business? They want more business. So that's the prize, because we actually don't have any money to give them real prizes. And so that's what we're actually doing with that. And so it's a very, very cool idea, but it's the idea that one of the pieces of behavior that we tend to overlook is the behavior that's embedded in processes. And so getting people to change their process behavior in procurement, in everything else, it becomes hugely important. So Judy's going to talk about some more stuff, and then I'm coming back at the end.
I'm going to talk about a little bit of research, just give some brief examples of the kinds of things that we're doing with the national labs and other research teams. I'm going to talk about coping with discomfort in the buildings, desktop plug load behavior change, and Kevin's going to come back and talk about a dual flush toilets and water use project that we had underway. How do I, this thing?
No, to the right, this one.
Oh, this one, okay. First of all, coping with discomfort. This is research I did several years ago when I was at the University of Washington, 7 Energy Edge buildings in the Pacific Northwest, and we are replicating this study and using the same kinds of methods at Fort Carson now in a series of buildings that we are studying there. So this is data from the Center for the Built Environment survey of GSA retrofits, and you find that if we are looking at air quality, temperature, and speech privacy, satisfaction is extremely low. Satisfaction with everything else is, you know, reasonably okay, but temperature conditions, which is what I'm going to talk about primarily, and speech privacy are really low. There was an article in the New York Times on Monday. Did all of you see it about acoustics in the office, the open plan office? They actually interviewed some folks at CBE and looked at sort of what is the survey telling us about acoustics and privacy. And acoustics is a sustainability issue, because as you move towards more open plan offices to bring daylight in, to use less materials because you're having lower panels, you are actually influencing the behavior of people in the environment, even though it's a sustainable solution. So what happens when people are uncomfortable or dissatisfied? This is, you know, a question that people don't really address very much, but I think it has real consequences for buildings and building design. First of all, they use 3 different coping strategies. One is to change the environment, one is to change their own behavior, and the third is emotional coping. These categories were drawn from the stress research that looked at how people respond to stress. And it is generally considered better to change the environment. There's a lower adaptive cost to doing that. So let's see what people do. This is daylight discomfort. And this is, it's pretty easy to just close the drapes if you have drapes or blinds there. So that's what 80% of the people did in these buildings was if the sun was too bright, they just went over and closed the drapes. Some of them drank something cold if they probably didn't have any control over this, so they went and got a cold drink. Others, if they couldn't have any control at all, just felt like there was nothing to do they could do about it. Sometimes they put up umbrellas. This is the Chesapeake Bay Foundation building in Annapolis, the first LEED Platinum building in the country. And I studied this for DOE when I was at the Pacific Northwest Lab. And they put these umbrellas up all along the route when the sun was really low in the sky in the winter. And if you think about it, if you can control the heat coming in, and blinds do that to some extent, this is a perfect solution. Because as soon as it's not real bright anymore, they close the umbrellas and put them down. They have complete control over it. It solves the problem. And we see this. Has anybody seen this in offices? It actually happens quite a bit. And I'm surprised these furniture manufacturers don't supply nice umbrellas now with their cubicles. This is thermal discomfort. The biggest problem next to noise. And if we look at this, more of them do behavioral kinds of things than the other 2 coping things. The one thing, those of you who are interested in facility management notice that a lot of them complain to the facility manager. This is one thing that facility managers don't like, is dealing with complaints from people. And somebody the other day told me that to solve this problem, they put in a sham thermostat that always reads the same temperature. And it satisfies people. It works. A lot of people, you adjust clothing. It makes sense to put on a sweater, take off a sweater. They adjust the thermostat if they have one. Most of them don't have a thermostat to adjust. And they also drink hot and cold drinks. But there's still an emotional coping level here where they say there's nothing they can do about it. And what happens when you say there's nothing you can do about it? You concentrate harder to try to ignore it. You get grumpy. Sometimes it's really difficult to work. So the emotional coping is not really satisfactory. Sometimes they cover up the underfloor air distribution vents. This is the Seattle City Hall. It's a LEED Silver building. And there were these all over the floor that I was doing. This is just the most aesthetically pleasing one. A lot of them put books, they put boxes. And the air was coming in too cold, and they were really trying to convince the building operator bring the air in warmer because it's coming right on the feet. And it was unusually cold. And this is another picture.
Judy?
This is also City Hall. Look at this picture, the lights are on. It's a corner office. And he's got a little coffee maker, he's got a printer, he's got a radio. This is plug loads on steroids. There are a lot of them who bring in these kinds of devices. Judy. And if we look at the acoustics, okay, this is going to be real quick. We look at acoustics and we notice that they engage in emotional coping for the most part. It's because there's nothing they can do about it. They don't go over and tell their colleagues to be quiet. They just kind of suffer in silence for the most part. And if we look at this then, just as a summary, 85% of the people who used the environmental coping said it solved the problem. This means it's very effective. And you saw less satisfaction with either the adjusting behavior or the adjusting emotions because they don't solve the problem. This is a very quick study. I'm going to go through a desktop plug load study at the EPA in regional office in Denver. And what we did was look at, NREL did this study. We worked with them to develop the protocol. And what we did was have all of the plugs at the desktop were plugged into certain outlets. And we had a system that automatically turned the lights off, or the things off in the desktop if people were gone for more than 10 minutes. So it was an occupancy sensor that sent the information and the things were turned off. One of the problems here is that the people refused to put their computers in it. They didn't want to have to come back after an hour, turn their computer, boot it back up, You know, it takes a few minutes. So they don't have computers here, so we're just looking at everything else they have in their desktops. One condition was the automatic turn off. The system itself did this. Then we had one in which we gave people information about how much energy their various devices used and suggest that they, you know, turn them off themselves. And the third one was a competition among the pods. So we had them, they could go to an external website that had the information on energy use. And they looked at the energy reductions for each condition and the estimated cost of the energy savings. This is my last slide. The findings showed that the automatic turn-off won. It did much better than people turning them off itself. Information made no difference at all. It was, and it actually, and this is the most often used strategy, is to give people information. And this is EPA. These are folks who care about this kind of stuff. So it wound up, they even went in the hole energy-wise on the cost savings. And what we found, though, when we looked at the return on investment, was that the automatic system was so expensive that it would have taken 48 years to pay back. So it obviously is not a good choice unless you get computers included in that. So it was an interesting analysis. The report will be out sometime soon, so you'll be able to look at it. So Kevin, I think we're back to you now.
Well, I think we've outstayed our welcome. So I'm going to suggest that you do want to hear about the chair. Okay, well then this is really simple and be very fast. Dual flush toilets in this building did not, you don't need to see the screen. You do not need to see the screen. Dual flush toilets in this building did not actually give the energy saving or the water savings that anybody expected, and we measured it. And this is why. There's the sign that explains it. There were two actual reasons. First of all, these were the signs that came with the fixtures. The plumbers who installed the fixtures threw the signs away because they didn't think anybody needed signs to know how to flush. Number one. Number two, let's say you get them all in, and it was very cheap to fix that. Oh yeah, and then they installed half of them upside down. Anyway, but then here's the problem. Now, you're seeing this sign, right? So I care about this, and I walk into the bathroom, and I see the flush valve right there on the back of the toilet. This is the toilet now, so the seat's down. And I have to, first of all, put on my reading glasses because it's actually much too small, and I have to stick my nose in the toilet in order to read it, and then I really don't actually want to use that one. Anyway, that's the problem, you know? This sign, this is not intuitive. The sign doesn't make any sense. This is slightly better than most because of the slightly bigger arrow. But I mean, what happened to the idea of a big arrow and a little arrow, or a big button and a little button, or get the idea, you know, it's make this really simple. And by fixing two things, by fixing the direction of the flush so that we're all the same. Oh yeah, by the way, which way is the natural way to push yes, down. These were designed so that, as you can see, the big flush is down. So it's the default flush. Let's think about what people's natural behaviors are and design it so that, you know, the opt-in, opt-out actually works here so that the natural behavior gives you the small flush, and then if you notice it, you flush again and you're still better off. So it's that kind of thing, really understanding how the behavior works. And it's a wonderful example because, number one, it starts with the specification. Don't go with these silly ones in the first place. And then it goes to the installation. You really have to make sure they're installed correctly. Then you have to actually make sure that the signs are legible, and not everybody who designs plumbing fixtures knows how to design signs. You have to make sure the signs are actually up there. And then you have to measure the results and realize that if you're not getting the results you expect, you need to come back and fix it, and then measure again. And now we're getting it. So that's actually what we really wanted to say about that. And so what we're going to do is try and get this story out on YouTube. There'll be somebody far more elegant than I who's actually sticking head in a real toilet. And, but you know, we have to get it out to people in the way that they want to hear about it. And so we're going to be using things like YouTube. And we're going to talk to the plumbers. We're not going to talk to them in the same way that I'm talking to you guys here. But you can talk to plumbers in the language that they use. by getting plumbers to do it. And that's sort of going back to that example of the chief engineer who taught me everything that I know, is to really come back and say, who's the best teacher? And the best teacher generally is somebody in the peer group. And so we're actually going to bribe people through a variety of ways to get them to do our teaching for us. And then I think the coolest thing that we're going to do is we're actually going to go measure the effectiveness of these various methods and then make them all freely available to anybody in this room, outside of this room. So that's our story. Thank you.